Okay, so let's talk about section 4 here. Parallel and perpendicular lines. We're still dealing with um, slopes. We're still dealing with all the line stuff we've been talking about the last few days. But today we're going to specifically talk about special relationships between lines, parallel and perpendicular. All right, well, we have a couple definitions here to go, and then I'll talk about kind of visually what things look like. But we talk about what parallel means. Parallel means that lines, they run right next to each other. They don't ever intersect. Okay, parallel lines never intersect. And what that means, in order for that to happen, it means the lines have the same slope, and that's key, same slope. Okay, so make sure you highlight that part, the same slope, but different y-intercepts. If we had had the same slope and the same y-intercepts, we would have the same line. And I'll show you what I mean by that here in a minute. Okay. Perpendicular lines, on the other hand, okay, are lines that have slopes that are opposite. Okay. And important, big capital letters, this is a both thing, reciprocals. They're flipped. So the signs are different. One's positive, one's negative, and they're flipped of each other. Okay. So if I look at that, kind of the same idea there, 2/3 and -3/2. Those are called opposite reciprocals. Okay, so that's what we're talking about with perpendicular lines. So the slope goes from there. All right, so visually what that looks like, if you don't understand that with what the definitions are, come down here to this picture and we'll kind of show you what we look like. If I look at line A here, okay, compare it to line B, if you notice they look like they're running about the same way. Okay, if I look at the slope of these two lines, if I start, like take a point, we'll say right here, and the next point right here. Okay, those are 2 points in the line. If I do that, I have a rise and a run to get there. My rise is 1. My run is 3. So the slope of A is 1/3. Okay, well, if I look at B and pick some value, let's pick this point here and this point here. Again, if I look, I go up 1/3. So the slope for B is also 1/3. So they have the same slope. Okay? But if I look, they cross the y-axis at two completely different places. Now I said, why is that important? Well, if I was to have the same slope, which these two lines do, okay, let's say I moved them, so they had the same y-intercept. Well, if I took this line and put it right on top, okay, if I notice, look what happens. It's the same line. Okay, they're not changing. It's going on the same rate. So we have to be careful when we do this to make sure that we have different y-intercepts so that we can keep things nice and separate. Otherwise, it's the same line. If they had the same y-intercept, same line. So we need different y-intercepts. And why they're parallel? Well, if they're changing at the same rate, they're never getting any closer or they're never getting any farther away from each other. So they're all keeping the same distance in between here. That's why two lines with the same slopes are parallel. Perpendicular, on the other hand, means they form a 90-degree angle. So I look at this guy, that forms a 90-degree angle. And C and D, well, if I look at the slopes of these two lines, okay, I'm going to pick a point and we'll go through. I'll pick this point right here and this point right here. That is going up and then over. That went up 2 and ran 3. So the slope of D is a positive 2/3. Okay, cool. Well, if I look at C now, I can start here and I can go down to here. That's a nice point. Here I went down now and over. So that's a -3 because I went down and over 2. So the slope of C is -3/2. Now, how can I tell whether or not things are opposite or reciprocals? Well, if I took their slopes, okay, I can kind of check this out. If I did -3/2 times 2/3. Well, if I do that, that's -6 over +6, which is -1. Opposite reciprocals will always have the product -1. So that's a quick check to make sure I'm using the correct slopes when you see the word perpendicular. And that'll help us kind of move forward as we go. So how can we apply this to a problem in writing equations for for problems. Well, here's the first example. Okay, find the equation. Again, keywords we're looking for. We're looking for parallel. We're looking for perpendicular. We're trying to help us figure out which one to use. So first of all, keyword parallel. Okay? So we ask ourselves, what does that mean? Well, parallel lines, remember they have the same slope. Okay? So that means don't change the slope. Now, we see it's parallel to this line and passes through this idea. Folks, all of this given line is 4. Okay? We're just going to use this to find the slope. I know my slope here is 3 over 2. We're using it for nothing more. That's it. 3 over 2x plus 7. The slope is 3. Don't change the slope because it's parallel. And I have a point. So again, what we're given, kind of going back to the lesson the other day about the different forms of a line, I've been given a point and a slope. So I'm going to use point-slope form. Remember this guy from a couple days ago. Y minus y1 equals m times x minus x1. We're going to plug that guy in because I have a point and I have a slope now. So I'm going to keep the slope because it's parallel and use my point. Okay? That's all I'm using this given equation for, is to figure out the slope. So y minus y1, that's 6, will equal my slope, 3 over 2, times the quantity x minus x1, which is 4. Okay, and then we simplify, just like we've been doing the past couple days. So y minus 6 will equal, distribute your 3 over 2 in, 3 over 2x, and then I have 3 times 4, which is 12, divided by 2, that's going to be 6. Okay. And the last thing we have to do is add 6 to both sides to get y by itself, and we get an equation. Y equals 3 over 2x, and then you can put plus 0 if you want there. You don't need to, but that's going to be our answer. So if I look to do a double check here, remember, parallel lines, same slope, different y-intercept. So the slope here is 3 over 2, the slope here is 3 over 2. So they have the same slope. That's good. Is my y-intercept different? It's 7 here, it's 0 here. Sure is. There is my parallel line. Okay, that's what's going to work for us. On the other side of that, we talk about perpendicular lines and how that can be used for us. Again, look for those key words. Perpendicular. That line, that word shows up. That needs to tell me something. Okay? So that tells me I need to change my slope. We're not keeping it, we're changing it because we're perpendicular, they're not the same. So again, we come to this line, this gives us information. The slope here is 5 over 2. So I need to change my slope. Now, I'm going to put the word first here, because quite often we see a change in the slope, but you do it at the wrong time. We change our slope first and then write our equation. Change your slope first and then write your equation, not the other way around. So if I start with this, my slope is 9 or 5 over 2. I'm going to make it the opposite reciprocal. So this is positive, so it's going to be negative, and then flip 2 over 5. So this is my new slope right here. This is the one I want to use. New slope, I have a point. Now we approach it the same way we did the parallel lines. We start with point-slope form. So y minus 3, that's y1, will equal my new slope, 2 over 5. Remember, new slope, x minus negative 10. Okay. Well, continuing on, we are going to just become plus and plus here and distribute the 2/5 in. So y minus 3 will equal a negative 2 over 5x. Okay. Negative times a positive is a negative. So 2 times 10, that's 20, divided by 5, you get 4. And then the last step, just add that 3 to both sides. So y will equal negative 2/5 x minus 1. Now, can we check to make sure that this is perpendicular? If I come back up here a little bit, I'm going to take the original slope, 5 over 2, multiply it by my new slope, negative 2 over 5. If I did it right, I should get negative 1. Well, 5 times negative 2 is negative 10. 2 times 5 is 10. That equals negative 1. Awesome. So I know my lines are perpendicular because the slopes are opposite reciprocals. I did my math right, and this is my final answer. So as we go through and do our work throughout the next day here, those are ways we can show that things are parallel and perpendicular. Slopes, 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 slopes. It's all about the slopes. Okay? If we have to remember anything about this, it's all about the slopes. Parallel lines have the same slope, so you need to show that the rates of change are the same. Perpendicular lines are opposite and reciprocal. Not one or the other, both. So we have to make sure that we are paying attention to that as we go through. So that's parallel and perpendicular lines. If you're not sure whether lines are parallel, find the slope. Solve for y. Put them in slope-intercept form, and then determine whether or not they have the same slopes, opposite reciprocal slopes. If they're neither, they just intersect. They're not parallel. They're not perpendicular. They just intersect. So if you find lines that have different slopes, but they don't follow this opposite reciprocal part, they just intersect, and there's no real special relationship between them. So that's our video. We'll take care of some stuff in class, and hopefully that clears things up for you.